Algebraic Proof word exam questions. Just a little comment to any of my students, my current students, that if there's something you want me to work on before we go back to school, then please do comment on this video, say what it is, and I will try to get to it. Okay, to start off with, a lot of these videos have as a key skill is being able to multiply out a double bracket, and possibly even in this question to realise that it is a double bracket. When you've got a bracket squared, that means the bracket times by itself. Now, lots of different ways of doing this. You can think about this as some sort of smiley face, which I've shown people before. You can draw yourself out a grid method, just like you might do for basic multiplication. But whatever way you've got to do it, you've got to remember there's going to be 4 parts to multiplying out 2 brackets when there's 2 bits in each bracket. Let's just use this one since it's here. So 3x times 3x, 3 3s are 9, x times x is x squared, 1 times 3x, 1 times 3x, 1 times 1. So we've got 9x squared plus 3x plus 3x plus 1, which is 9x squared plus 6x plus 1. And there's your answer. Now, when you're trying to show something or prove something, most of the time you're starting with the left-hand side, you ignore the right-hand side, and just work through the left-hand side until you make it look like the right-hand side, and then you've shown it or proved it. Okay, you're given some examples. This is indivisible by 12. Given an example of 3 consecutive integers with a product that's not divisible by 12. Now, quite often, if you go backwards on these, so 1 times 2 times 3, that's 6. That's clearly not divisible by 12. And if you go forwards, 4 times 5 times 6, that's going to be 20 times 6 is 120. That's divisible by 12. But 5 times 6 times 7 is 30. 30 times 7 is 210. So either 1 times 2 times 3 or 5 times 6 times 7 would work there, or there's probably loads more. Just keep going. And quite often with these sort of questions, if you're not sure what to do, if you do some examples, if you do 3 or more examples of you trying to work something out, you tend to get a method mark. This part B, explain why the product of 3 consecutive integers is divisible by 6. Now, you might be tempted to start thinking about n times n plus 1 times n plus 2. If we multiply that out, we're going to get some sort of cubic, which is far too complicated for a 2-mark question. So when it says explain, it probably means just to think about talking about the numbers and what's happening. Why is it always divisible by 6? Well, if you've got 3 consecutive numbers, one of the numbers is a multiple of 3. If you think about it, 3 consecutive numbers, it doesn't matter what 3 numbers you've got, if you start anywhere, one of those 3 numbers is going to be a multiple of 3. Second thing, one of them is even. Again, every other number is even, so in 3 consecutive numbers at least one of them is even, and multiplying a multiple of 3 by an even gives a multiple of 6, and that should be enough. Okay, showing this, so start on this side, the more complicated side, try to work to the easy side. Again, multiplying out a double bracket. This time I'm going to do it using the smiley face method. So there's a smile, there's the eyebrows. N times n is n squared. N times plus 3 is plus 3n. Minus 2 times n is minus 2n. And minus 2 times plus 3 is minus 6. And that's going to be added to 6 minus n. Always be careful when you've got brackets and signs, especially negatives, the plus sign means these can be whatever they are in the bracket. So we've got n squared plus 3 minus 2 is n minus 6 plus 6, and then we minus the n again. So the n's cancel and the 6's cancel to give us n squared. And that's enough to show it. Show that this is a multiple of 4. Again, multiplying out the double bracket, m plus 2 times m plus 2. When you get good at these, you'll be able to just do them in your head. So m times m is m squared, m plus 2, 2m, and 2 times 2 is 4. The m squared cancels, the plus 4 cancels, to leave us with 4m, therefore multiple of 4, because 4 times anything is a multiple of 4. Some terms in the sequence. This is the nth term. Show clearly why the n plus 1th term is this. Well, if you take the nth term and just replace the n with n plus 1, so that's n over n plus 1, that's the nth term, but I'm replacing the n with the n plus 1 plus 1 to get n plus 1 over n plus 2, and that's enough for 1 mark. Now, showing the difference between the two things is this. Then we've got the difference means to take them away, so a bit of algebraic fractions. I need to put them all over n plus 1, n plus 2. And this one I've times that by n plus 2, I've times that by n plus 1, so I've actually got n plus 1 times n plus 1. And this one I've times by n plus 2, so I've got n times n plus 2. And that gives me this top bit. When you multiply it out, make sure you use a proper method to remember how to do this. You get n squared, you've got n and n, which is 2n plus 1 all over n plus 1, n plus 2. Always look to see what you're trying to get. I don't need to do anything with that bottom bit because I want to leave it as n plus 1 times n plus 2, and I've got n squared plus 2n over n plus 1, n plus 2, and then I need to combine those. So I've got n squared minus n squared is nothing, 2n minus 2n, be careful with that, is nothing, and I've got 1, and that's just equal to 1 over n plus 1, n plus 2. Probably could have done with another extra line of work in there, but ran out of space. 4 consecutive integers, prove this. So this is our left hand side and this is our right hand side. Now this question we need to work on both sides, so if I separate them out, left hand side we've got p plus 3, because p is p and s is p plus 3, and I'm adding 2 to that. On my right hand side I have q times r, which is p plus 1, q is p plus 1, that's that one actually, p plus 1, that's q, and that's r, and that's s, and I'm timesing that by r, which is p plus 2, so multiplying these out I've got p squared plus 3p, and then I've got the plus 2. On this side I've got p squared, p times 2, p times 1 is 3p, and 1 times 2 is 2, and therefore left hand side equals right hand side. Let me prove that. Prove that the product of two odd numbers is always an odd number. No extra help there, so this is quite tricky to know what to do, but most of these odd even questions are to do with using even numbers. So if we say n is even and m is even, then our two odd numbers could be n plus 1 and n plus 1. So we multiply n plus 1 times m plus 1 gives us nm plus n plus m plus 1. Now, this is even. So even times even is even. This is even. This is even. So we've got even plus even plus even plus 1. So this is an even plus 1, which equals odd. Now for 2 marks, I don't think we need to say anything more about n and m being even, but we could say even times even is even. We could explain that a bit more detail, but it's only 2 marks, so I can't think it needs more than that. To give a counter example of this, this is a calculator question. I mean, again, I would just jump back to 1 cubed minus 0 cubed, which is 1, and 1 is not prime. The first prime number is 2. But you could go up through the numbers. 5 cubed minus 4 cubed. It's probably not going to be the first one after this. 61 is prime. And then we've got 6 cubed minus 5 cubed. That's equal to 91. Now 91 is not prime. It happens to be equal to 7 times 13. But you may not have noticed that, but that's the first one. And you could try some more until we find another one. But that will do. Prove this. So n plus 5 squared is going to be n plus 5, n plus 5. That's n squared plus 10 n plus 25, and you want to take away n plus 3, n plus 3, whoops, started to use x's there, which is n squared plus 6n plus 9. So I'm subtracting those two to give me, well, the n's cancel, so we've got 4n plus 16, and that's equal to 4 brackets n plus 4, which is the answer. Okay, given n is an integer, a whole number, prove that this is not a multiple of 2, so we'll just multiply all out, see what we get. N times 2n is 2n squared, n times 1, 6n, 3 plus, so that's the first bit. Second bit, n times 2n is 2n squared, n times 1 minus 2 times n, and minus 2 times 1. So we're going to add those two together. We get 4n squared, that's 7n, 8n, take away 4 is 4n, plus 3, take away 2 is plus 1. Okay, we could just say these two are even plus 1 equals odd, therefore not a multiple of 2. We could be a little bit tidier, we could go 4n squared plus n equals even, because it times it by 4, but I think that's enough for 5 marks. Prove this, so last couple of questions are algebraic fractions. Ignore this bit, start with this, combine it, hopefully you get that. So to combine these two fractions, we need to make a common denominator, so we multiply the x by the x plus 1, and then we multiply the x plus 1 by x. So this one I've multiplied by x plus 1, so I times the top by x plus 1, so I've got x plus 2, x plus 1. This one I've multiplied by x, so I have x times x minus 1. To combine those, I need to put it all over one fraction, which is the common denominator. Multiply out this left hand side, I get x squared. Should be good at these by now. 2x, x is 3x. 2 times 1 is 2. Now the second one, I recommend first of all multiplying it out, because it's a take away. Multiply out the bracket and keep it in a bracket so you don't mess up the signs. So we've got x times x squared, x times minus x, and then we've got x squared plus 3x plus 2. And then we're going to minus the x squared, then we're going to minus the minus x, which is plus x. The beauty of this is you've actually got the answer here. We could use that to help us to realise that's what we're trying to get on top. So if you make a mistake with the negatives, should help you. But don't just fiddle it. Try to make sure you get it right. So x minus x squared goes. 3x plus x is 4x plus 2 all over x, x plus 1, and just to finish off we need to factorise out the 2 from the out of the brackets. Get the answer. 4 marks. And one more algebraic fraction. Again, ignore the right hand side apart from to know that's what you're trying to achieve. Start on the left hand side, common denominators. We need to get x plus 2, so it tells you you've got to multiply these together to get a common denominator. Again with a negative sign. So this first one I've multiplied by x plus 2. The second one I've multiplied by x. So I've got x plus x minus 3. X minus 3, x plus 2, and the second one I've times by the x. I've got x lots of x minus 2, because it's minus 2 there to start with. Combine those over one fraction line, so x times x squared, minus 3x plus 2x is minus x, minus 3 plus 2 is minus 6. Again, we're going to take away the second bit, so I'm going to put that into a bracket so I can work this out. X squared minus 2x. If you're really good with this, you can work this out as you go along, but it's quite easy to make mistakes with the negatives otherwise. X squared minus x minus 2 minus the x squared minus minus, which is plus 2x, all over x, x plus 2. And the x squareds cancel. Minus x plus 2x is x, and you got minus the 6 over x, x plus 2. And there we go.